Let's see the first data link control protocol, which is HDLC, High Level Data Link Control. Let's start the session with the outcomes. In today's session, we have 3 outcomes. Upon the completion of the session, the learner will be able to: outcome number 1, understand bit-oriented protocol. Outcome number 2, know the frame format of HDLC. And outcome number 3, we will know the types of HDLC frames. We will start the session by having a recapture over the bit-oriented approach and a bit-oriented protocol in brief. A bit-oriented approach where everything is viewed as a sequence of bits. It simply views the frame as a collection of bits. The bit-oriented protocol is the HDLC, which is High-Level Data Link Control. Let's see what is HDLC. HDLC stands for High-Level Data Link Control, and it is a protocol in data link layer. Actually, HDLC is the name of the protocol, which means it is Synchronous Data Link Control Protocol developed by IBM, and it is an example of bit-oriented protocol. And this HDLC was standardized as HDLC. Who approved this standardization? Let's see it now. HDLC was later standardized by the ISO as the High-Level Data Link Control Protocol. HDLC is a very important protocol in data link layer. Not only widely used, but still it is the basis for many other data link protocols. And it is a bit-oriented protocol. Let's see what is the frame format of this HDLC protocol. The frame format includes: the starting will be the beginning sequence with 8 bits, and then comes the header, which is of 16 bits, and then comes the body, which is a variable length body. We can't define the size of this body because whatever we receive from the network layer, that information only will be there in the body. And then comes the CRC, which is cyclic redundancy check, which is of 16 bits, and finally the ending sequence. If you note here, the beginning sequence and the ending sequence in HDLC protocol are the same. Let's see the fields in the frame format one by one. Let's start with the beginning sequence and the ending sequence. In HDLC frame format, the first field is the beginning sequence and the last field is the ending sequence. So HDLC uses these 8 bits as the beginning sequence and the ending sequence. 0, 1, 1, 1, 1, 1, 1, 0. It means 0 continues 6 ones and then 0. Whenever any frame is created, the starting sequence and the ending sequence, that is the start of the frame and the end of the frame, will be with this sequence. And this beginning sequence and ending sequence is not only for the start of the frame and the end of the frame, it also does an additional functionality. And this sequence is also transmitted during any times that the link is idle, so that the sender and the receiver can keep their clocks synchronized. For example, if there are 2 nodes and if these 2 nodes are not involving in data exchange for a long time, this beginning and ending sequences will be transmitted at any time just to synchronize their clocks, so that the link can be alive and the clocks are also synchronized. So far we have seen the beginning sequence and the ending sequence. Now let's see the header. The header has 2 fields. One is the address field and the other one is the control field. Always remember, header, which is of 16 bits, has 2 fields. One is address field and the other one is control field. This address field is an expandable one and the control field has its own significance in the types of frames. And let's see the third one, which is the body. And the body, we will also call it as a payload, and obviously it is of variable size. Why? Because from the network layer, whatever we receive, that is what will be there in the body part. And finally, we will see about CRC. CRC means cyclic redundancy check. We have already seen that in the data link layer, whatever the data that is received by the upper layer, it is going to add the header and the trailer. What the header will normally have? The header will normally have the beginning sequence or the preamble or the start of the frame. Header will have address and control field, and then the trailer part will have error detection related things like CRC, and the final one will be the ending sequence. HDLC frame format is the basis for other frame formats in the data link layer. And that's why we call HDLC is one of the powerful protocols. So far we have seen the frame format. Now let's see the types of frames. We have basically 3 types of HDLC frames. When we have 3 types of frames, which field is responsible for each of the frame? We know in the header of the HDLC frame format, we have 2 fields. One is the address field, other one is the control field. This control field has a role in identifying the type of the HDLC frame. The type of frame is determined by the control field, and this control field is a part of the header. Basically we have 3 types: Number 1, iframe, it means information frame. Number 2, S-frame, which means supervisory frame. And the last frame is U-frame, which is unnumbered frame. Let's see how the types of frame are determined by the control field. In the control field, if the first bit is 0, then it is an iframe. That means this frame is going to carry the information. In the control field, if the first 2 bits is 1, 0, and it is a supervisory frame. Supervisory frame has some role in error control and flow control mechanism. And the final frame is the U frame, which is an unnumbered frame. If the first 2 bits of the control field is 1, 1, then it is a U frame. Why do we need U frame? This U frame is for doing some miscellaneous activities. Say for example, link management related things. And that's it about the types of frame. In today's session, we understood the bit-oriented protocol called HDLC, and we know the frame format of HDLC, and finally we know the types of HDLC frames. I hope you guys enjoyed the session, and thank you for watching.